Okay, welcome back to the third video. Let's do some examples on these acute right triangles using the formulas we learned in the last video. So my first example shows an acute right triangle, and you can see that we cannot use the Pythagorean theorem because we only know one side, and we also know that this is not a special right triangle. It's neither a 45-45-90 nor is it a 30-60-90. So we need to use trigonometry, all right? And what we notice is that we're given an acute angle, and what we need to do is label all of the sides in relation to this acute angle, all right? So the first thing we're gonna do is label the 15 as the hypotenuse, and I'm just gonna abbreviate if you don't mind. I'm gonna call it hype. And we're gonna label the x, since that's the side across from the 53, as the opposite. Again, I'm just gonna abbreviate. Okay, now technically this side here would be our adjacent side because it's next to the 53, but there's no information given on the adjacent side. So our first decision is which set of formulas, the first set or the second. Notice that we're looking for x, and x is a missing side. So what we want to do is use the first set of formulas, and we need to pick the formula that makes the most sense. The formula that will allow us to solve for x, given the fact that we know the hypotenuse and we're looking for the opposite side. So let's look back in our notes to our original formulas, and we want to definitely go up to the top. These top formulas allow us to find missing sides. I want to use sine of theta equals opposite over hypotenuse because I am looking for the opposite side and I know the hypotenuse. I'm also given theta. I would not want to use cosine, right? Because I am not given the adjacent side. And if I am not given the adjacent side, there's no point in using that formula. Again, tangent would also not work because I don't have the opposite and the adjacent side. So my best bet is to use the sine of theta. So the way this works is actually pretty straightforward. We're gonna fill it in together, and I'm gonna use my scientific calculator. So I'm gonna say that the sine of theta is equal to opposite over hypotenuse. And I'm gonna fill in my information. So it's the sine of 53 degrees. Okay, you wanna make sure that's in degrees, equals the opposite, which is x, over the hypotenuse, which is 15. Okay, now, my advice would be in order to solve for x, what would make the most sense is to put the sine of 53 over 1. Now we have formed a proportion where two fractions are equal, and the easiest way to solve is to cross multiply. So x times 1 is x, and that equals 15 times the sine of 53. And I would put the 15 in front because when you type it in your calculator, it'll be less confusing. And now at this point, you literally need to type this into your scientific calculator. There's no way you should know or memorize the sine of 53 degrees. If you don't have a scientific calculator, I know that your cell phone can do this calculation. You might have to play around with it to make sure you get the right number. It's a little bit tricky. But I'm gonna type this in, 15 times the sine of 53, and I get roughly 12. Okay, so make sure you're getting roughly 12. It could be off due to rounding.